Hi, I'm Jeff Duffy, Senior Technical Advocate at AWS. I'm joined today by Deepak Thukral, Vice President at McAfee, and Kanish, Senior Solutions Architect at AWS. And I'd like to talk to you today about which NoSQL database is best for your workloads. When I say SQL, it is easiest to compare to a relational database to understand what I mean. And what I mean is a database that is purpose-built in order to serve certain kinds of workloads. So typically, NoSQL databases, when you compare them to a relational database will have normalized data structures where we try not to duplicate data and we'll break that data up into individual tables and then join them when we do our queries in order to minimize the use of storage. NoSQL databases tend to have denormalized data where we'll exchange the duplication of data in our database for faster queries. Relational databases tend to offer strong read consistency as a rule, whereas non-relational databases can offer eventual consistency as the default, though, of course, many NoSQL databases do offer strong consistency in reads. Relational databases tend to have vertical scaling, where all of the components of a particular node when you're deploying tend to get scaled together when you need more resources, whereas NoSQL databases tend to be architected from the ground up in order to scale horizontally to serve very large workloads. And when we design for a relational database, we tend to think about our data in an entity relationship-based model where we're trying to figure out what the relations between the data are when we design that data model. Whereas when we design for a NoSQL database, we tend to think about access-based data modeling and thinking about how we're going to use the data when we figure out how to represent it in the database. So at AWS, we talk a lot about our purpose-built databases. And the NoSQL database types that you will tend to see, starting from the left here, are with key value databases. These are databases where you're going to retrieve data by its key. They tend to have very low latency and extremely high performance. And you'll see them used in inventory and metadata tracking applications. Wide column databases take that key value and add some functionality in the sense that we can have multiple columns that we can query on. But they also tend to serve very high throughput workloads, and we see them used for trade monitoring and fleet management applications. Document databases offer the ultimate in flexibility, where you can have complex and nested data. You can query on any attribute in that data, including nested attributes. And this is very popular in content management and gaming applications. In-memory databases offer extremely low latency retrievals in the microseconds and can offer some very specialized data structures to serve very particular use cases like leaderboards or caching. Graph databases allow us to create and navigate relations between sets of data very easily and quickly. So for instance, if we wanted to create a social network graph or build a fraud detection system, a graph database might be a pretty good choice for that. Time series is all about doing analytics over large amounts of data that's organized by time, something we see a lot in the IoT and healthcare fields, and also utilization metrics make heavy use of time series. And then finally, a ledger database provides us an immutable, sequenced, cryptographically verifiable history of changes. So we know that when an entry is made, we can prove that it hasn't been modified after the fact. And that's really important for things like supply chain tracking or financial systems. And you'll notice in this graph that on the left side, we have the more general purpose NoSQL databases. And as we progress to the right, we tend to get more specialized in what those databases are used for. And today I'm going to talk about these three at the left, the key value, wide column, and document. So AWS offers a number of fully managed NoSQL databases, including for these three types. And we'll start with talking about our document database type, which is Amazon Document DB with MongoDB compatibility. For wide column, we offer Amazon Keyspaces for Apache Cassandra. And for key value, we offer Amazon DynamoDB. And these are all secure and highly available databases. They offer high durability, and they are all fully managed. And so you can expect for all kinds of enterprise features like multi-AZ deployment, encryption at rest, point-in-time recovery, and managed backups are all offered in these databases. So diving a little deeper, starting with Amazon Document DB with MongoDB compatibility, which is a fast, scalable, fully managed and Mongo compatible database service, right? This is a service that's going to offer you very high performance. It can serve millions of read requests per second with very low latency. And its architecture separates storage and compute, which makes it really easy to scale horizontally to offer very high read workloads. DocumentDB is fully managed, which means you don't have to worry about provisioning hardware or patching the operating system. It's very fast and easy to set up, and it offers features like, automatic backup, so you don't have to manage them yourself. And it's MongoDB compatible, so you can use the same drivers and applications that you use today with Mongo 3.6 and 4.0 APIs with Amazon DocumentDB. So the DocumentDB data model offers JSON-like documents, and these have field value pairs. A bunch of documents are saved in what's called a collection, which is kind of like a table in a relational database. And DocumentDB supports a lot of rich data types, timestamps and booleans and so forth. DocumentDB supports nested data structures within a document. So you can have documents inside of other documents. And you can query on any attribute in a DocumentDB document. So that means if you want, for instance, to find out some piece of information that's in a nested document, you can do that. And you can index on those as well, so your queries can be performant. The DocumentDB architecture is instance-based, and so at the top of this slide here, you can see where we're going to have compute instances. You have to have at least one, which is called your primary, and you can have up to 15 read replicas as well. Your data is stored, as you can see in the lower part, in this distributed storage volume, which stores your data 6 ways across 3 availability zones for extremely high durability. DocumentDB is a single writer only architecture, which means you can only make changes, writes, or updates to the primary instance, but you can read at an eventually consistent level from any of the replicas. And so it works really well to scale to very high read workloads. When you want to query DocumentDB, you're going to use the MongoDB query language. And so that means, as you can see in this example in the upper right, I'm going to run a query in a collection called players, and I want to find the documents for which the nested value of shellgame.bonus levels, and you can see on the left here, bonus levels is in a sub-document of my document here, is set to the value true. And this query would return all of the documents in that collection for which that was true. DocumentDB lets you pick your read consistency options using settings in the drivers, and you can achieve read your writes consistency from the primary or eventual consistency from read replicas, and it does support transactions. Next, I'll talk about Amazon Keyspaces for Apache Cassandra, and this is a fully managed service that is compatible with Apache Cassandra. It's a wide column service that's performant at large scales, and it's highly available and secure. And Amazon Keyspaces offers the data model where you store data in rows of columns up to 1 megabyte in size. And this looks a lot like a relational database at first glance. Rows are stored in tables. But we can group related tables into what we call keyspaces as a way to sort of think about related data. Keyspaces offers basic data types like integers and booleans and blob data for binary, and it also supports nested data types. So you can have lists of data and maps and so forth. When you store data in Amazon Keyspaces, you have to store your row with a partition key. That partition key can be defined as multiple columns in that row. And you can also choose to have optional clustering columns, which will let you define ways that you can sort your data when you retrieve it, though there are some size constraints for these clustering columns that you define. You can see at the bottom an example of how you can create a table in Amazon Keyspaces, and it looks a lot like pretty standard relational SQL. In my example, I've chosen to have 2 elements in my primary key, but I can store, as you can see, lots of different kinds of data that'll be useful to retrieve later. So when you query Amazon Keyspaces, you use the Cassandra query language, which has some very SQL-like functionalities. It lets you do things like filter with predicates via a where clause, and you can use order by segments in your query to use those clustering columns to sort your data even in multiple directions depending on how you've defined it within your table. And an example of a pretty standard query is shown here at the bottom. It looks a lot like an SQL query from relational database, and that last allow filtering is the signal to Keyspaces that you're okay with retrieving a bunch of data that you're going to filter out before you bring it back. Lastly, I'd like to talk about DynamoDB, which is a very fast and flexible NoSQL database to operate for data that happens at any scale. So DynamoDB can handle millions of requests per second, and it offers single-digit millisecond latency for retrieving single items from DynamoDB. And it offers features like global replication of tables in order to allow you to build very large and very high-scale applications. DynamoDB is completely serverless, which means it's maintenance free. You can have it scale for you, so you don't have to manage capacity. You can choose the on-demand capacity mode for Dynamo, which allows you to let Dynamo scale your resources up and down as your traffic grows in order to make sure that you don't have to worry about provisioning certain amounts of traffic for your application. It is ready for enterprise applications. It offers features like transactions, encryption at rest. It offers rich tooling like the NoSQL Workbench, which lets you write queries and test them out in DynamoDB, and supports the particle language, which is an SQL-like query language optimized for NoSQL databases. And DynamoDB has rich integration with other AWS services. For example, Kinesis Data Streams, which lets you send changes that happen to your DynamoDB tables and use them, for other applications like putting them into a search engine, for instance. And CloudWatch Contributor Insights, which lets you monitor traffic based on your utilization to find out where opportunities exist for optimization. So DynamoDB can hold items. Items are the basic container of data, and they can contain any number of attributes stored up to 400 kilobytes in size. We store those items in what is called a table. And DynamoDB items support both basic data types like strings and numbers, and also booleans, binaries, and the null type, as well as nested types like lists and maps, which are containers of data within your item. So DynamoDB items have to have a partition key. It's how you store and retrieve data from Dynamo. And that partition key has to be unique if it's the only key that you use as the primary key. You can also optionally specify a sort key, and this is used for doing range style queries. When you do this, your primary key then for storing and retrieving data from the database is called a complex key, which is the combination of your partition and sort key. Finally, DynamoDB allows you, or requires rather, that you use the partition and sort key when you're doing queries on the database. But if you discover after you've modeled and inserted your data in DynamoDB that you have a different access pattern that needs a different primary key, it offers a feature called a global secondary index, which allows you to reindex data from a table in a different way to enable access via a different primary key. So the way that DynamoDB's architecture works under the hood is that partition key is used to apply a hash function, and your data is stored in 10 gigabyte partitions in DynamoDB. So this table is going to consist of at least one or more of these 10 gigabyte partitions, which automatically grow as your data grows in order to offer you that nearly infinite scale, based on your application's needs. And as you continue to insert more data and you'll have different partition keys, they will hash out to different partitions, allowing that to scale quite wide and give you that, really great throughput. So when you query DynamoDB, there are three methods of accessing data in Dynamo. So the first is a single item access, and getItem is the example operation for Dynamo that you would use to retrieve a single item by its primary key. Queries allow you to retrieve multiple items that have the same partition key, and that sort key that we talked about, you can apply condition filters to say, I want all of the items with a given partition key, but only if they match the condition for the sort key, that maybe, a date that's greater than a certain time, for instance. And then a scan allows you to retrieve all of the items from a table. This is something that you're going to want to use with caution, because getting all of the items from the table is a pretty expensive operation, and it's typically only used when you're doing things like exporting data for use for another database, for instance. And at the bottom, we see an example query in Dynamo, right, where we're going to have a table name that was MovieFacts, and I can have a key condition expression, which is going to allow me to say that I only want items for whom the director is named Joe Directure. Some notable features for DynamoDB include global tables, which allow you to take a table and replicate it across multiple AWS regions to get that data closer to where maybe your customers want to access it. That replication happens automatically. You don't have to do anything special. It's very easy to set up. Change data capture is offered for Kinesis, and so you can take changes that happen to your DynamoDB database and use them to do other things in other systems with. DynamoDB Streams is a way where you can take change data capture output for systems other than Kinesis and use it, for instance, to maybe write that data to S3 or OpenSearch as a way to build a complete system for your application. The DynamoDB Accelerator is a service that is a write-through cache that can sit directly in front of DynamoDB, where you can write through and read data from it, and it will automatically cache frequently used items. So if you have an application that needs to take you from that single-digit millisecond retrieval time frame to microseconds, DAX might be a great option. And then finally, export to S3 is natively supported. So if you want to take your DynamoDB tables and use them within, a larger workflow that has data stores in S3, it's pretty easy to do. So some indicators about when you might choose to use DocumentDB include if you need MongoDB compatibility, DocumentDB is a great choice. Like I said, compatible with 3.6 and 4.0 APIs. And in many cases, if you have an application you're using with Mongo today, you may be able to use it with DocumentDB without making any changes at all. DocumentDB as a document database offers you that maximum data model flexibility. So, if you're not quite sure what your access patterns look like today, and maybe you're going to make a lot of changes over the next few weeks as you design your application, it's quite easy to do in DocumentDB. And the ability to query nested data is really important for some customer use cases who want to be able to have documents within documents, but be able to query on information in that nested document. So read-heavy workloads that can tolerate eventual consistency are a really good choice for DocumentDB because of its architecture. And of course, workloads that need to scale up to 64 terabytes of data, which is the maximum storage volume limit for DocumentDB. For Amazon Keyspaces, we're going to be thinking about Cassandra compatibility. And if you have already built an application against Cassandra, maybe you want to think about migrating it to Keyspaces. Or if you're just really comfortable with CQL and you want to keep using that, but you're looking for a more fully managed solution, Keyspaces is a great choice. Keyspaces also allows you to validate schema as you insert it into the service. As I said before, defining those columns, you can potentially do multiple independent sorts when you retrieve data from a query, which is important for some customers. And allowing you to store data in rows up to 1 megabyte in size can sometimes help customers with a particular need. Finally, DynamoDB is definitely a great choice for workloads with well-defined query patterns, right? And so if you need that single-digit millisecond latency for retrieval for single items, if you need a database that can scale to nearly infinite scale, if you know today that you have a certain amount of data that you need to store and that data may grow unbounded in the future, DynamoDB is a great choice because it effectively has no largest table size. DynamoDB is one of our oldest NoSQL offerings, and it has an extremely mature and rich feature set, and it has super tight integration with lots of AWS services like S3 and Kinesis, and allows you to build some pretty complex and very rich applications. So now I'd like to turn it over to Kanish and to Deepak, who are going to talk to you about how McAfee chose DynamoDB for their use case.
Thanks, Jeff. I'm Kanish. I'm a solutions architect at AWS, and I'm joined here today by Deepak Thakral, Vice President at McAfee. And we're going to talk about McAfee's use case of modernizing e-commerce using DynamoDB. So I'm going to briefly talk about one specific application that drives marketing campaigns at McAfee and how we modernize that on DynamoDB. Then I'm going to hand it over to Deepak, who's going to talk about the overall e-commerce transformation at McAfee with DynamoDB, as well as delve deeper into this application. So next generation messaging, NGM, is an application that drives marketing campaigns at McAfee by delivering personalized content to over 30 million subscribers today. And it also calculates key performance indicators to measure campaign performance, such as conversion rates or opt-in rates and so on. We were able to modify NGM on DynamoDB in 4 specific areas. 1, we were able to provide horizontal scalability to NGM by converting this relational schema with lots of hierarchical data and multiple joins into a 2-table design by leveraging DynamoDB's adjacency lists to capture many-to-many relationships, as well as we were able to analyze query logs and understand access patterns and thereby optimize querying for these tables using global secondary indexes. From a cost perspective, NGM benefits using DynamoDB's application auto-scaling that enables the NGM consumed capacity to stay within a target utilization, as well as NGM only pays for storage that they consume through storage scaling in DynamoDB. From a performance perspective, NGM leverages DynamoDB Accelerator that provides in-memory acceleration for read queries. And NGM does approximately 8 billion reads a month. So DynamoDB Accelerator actually also saves cost to NGM because for all the read queries it serves, it saves on actually doing read capacity provision on read provision capacity in DynamoDB. The NGM application sits inside a VPC and connects back into DynamoDB through a VPC endpoint, thereby providing reducing network latency and also providing optimal security to the application. We introduced several operational efficiencies to the NGM application using DynamoDB. I'm going to cover two. In the first case, NGM leverages DynamoDB's global tables that enable its tables to be deployed across multiple supported regions using DynamoDB's multi-master replication. We're able to provide continuous backups to the NGM application. NGM does approximately 2 billion writes a month. So with those many large updates, it's hard to do continuous backups. But DynamoDB's point-in-time restore functionality allows us to take the table state back to a certain chosen time and date without consuming provision capacity on the table. With that said, I'm going to hand it over to Deepak, who's going to talk more about this application as well as the e-commerce transformation journey with DynamoDB at McAfee.
Thank you, Kanishk. Hello, everyone. My name is Deepak, and I'm really excited to be here today to talk about how McAfee is using AWS and DynamoDB to power our next-generation messaging platform that helps drive our e-commerce business here at McAfee. Before I talk specifically about DynamoDB and the next-generation messaging platform, I'd like to take a few minutes to give you an overview about McAfee, its core mission, and the e-commerce business. So here at McAfee, our core mission is to help protect consumers wherever they are online, right? And how do we help them? We do it by securing their digital lives and protecting them whether they are on their PCs, mobile phones, tablets, or browsers. Right? In order to do that, e-commerce plays a big role in helping consumers come to our website, discover these cybersecurity solutions, have a seamless experience in purchasing it. We have three strategic pillars on the e-commerce side. The first one is around subscribers, which enables subscribers to discover our solutions on www.mcafee.com, have a seamless checkout once they've decided which plan is relevant for them, and we have a variety of payment methods that enables these tens of millions of consumers to land and purchase products seamlessly. But also, the second pillar is what I would call as a transformation, where we are in the midst of this journey to move from an on-prem hosted solution to a cloud-scale website, cart, as well as a marketing technology platform that provides omni-channel messaging, of which NGM, or the next generation messaging, is a key part of that. The third is what we're calling as partner enablement, by which partners such as Verizon, T-Mobile, Sprint, and their subscribers can seamlessly use McAfee solutions and our customer portals to access their cybersecurity solutions. So you might wonder, how are we doing that? And what I'm going to show you next is how e-commerce powers this subscription platform. We basically have a set of user flows where these consumers are finding us either through Google and Bing on SEO, or they land on a web store, or in many cases, these subscribers get a 30-day trial version on many of the world's laptops. So whether it's an Asus, Dell, Lenovo, HP, they get this trial version, and they could also be coming in to renew, or they could be on an Adobe channel or Samsung. But no matter where they are, they find this trial version, they start to interact with it, and then we provide messaging. Think of it as in-app push messaging, except that it's on a desktop app. And that's what is the messaging platform that we are hosting right now on AWS and on DynamoDB. When consumers see these messages, whether they're on email or messages on these toaster alerts or SMS or app, they engage with them, and they're trying to understand how to upgrade to a paid subscription so we can protect their cybersecurity solutions and their family members. Or they might be like wanting to engage and adopt it on other devices. They'll click on that, and then they land on a landing page on a website from where they can start the checkout, the orders, and then the post-purchase download and activation. And then underneath all of this, we're using a marketing technology to provide omni-channel journey orchestration, a customer dashboard, a global payments platform, as well as auto renewals of our subscriptions, right? And you might be wondering that, where are we in this transformation journey? And how is this cloud, AWS, and DynamoDB helping us? So let me just talk a little bit about the from and the to. And where we started from, we had a monolith applications hosted on-prem data centers in the US. And the uptime honestly wasn't that great. We were at 99.9%, which means that we would see up to 8 hours of outages. And when that happened, you know, it undermined our credibility to our customers, to our internal stakeholders, that we cannot get messages out, we cannot process orders and transactions. And of course, that uptime is critical to running a multi-billion-dollar e-commerce consumer business. Secondly, time to market, right? Speed is a feature. And we were launching features only once a month. We had a lot of manual QA going around, so there were bugs and defect leakages to production. And then the data platforms were siloed. So what happened on a PC or a mobile or an email was not always stitched together. The journey that we are in the midst of is moving towards an e-commerce stack that's cloud native, microservices based, 4 nines of uptime. So we're really talking about minutes of downtime in a year. That drives up net promotion scores higher externally and internally. And 100% test automation, faster time to market, and then really unified profiles to power up messages that are driven by ML-driven audience segmentation and message orchestration. Now let me jump into it and talk about how is this next generation messaging platform powered by DynamoDB helping us. So key tenet of that is marketing automation. And what we do is we provide hundreds of millions of dynamic content and personalized messages, depending on the OEM manufacturer, depending on the region you are in, depending on which stage of the journey you are in, right? And then as part of any messaging platform, some of the key metrics we look at is deliverability. Did the message reach 100% of the targeted audience? What were their open rates? Is the message engaging? Are they clicking on it? Once they click on it, is it resulting in a visit to our website and checkout and a conversion into a paid subscription? Are they opting out of this stage? And what is the overall bookings or revenues that we get from here? Secondly, how are we getting these messages to reach a global scale to 30 million plus subscribers, and that to growing 15% year over year, right? And in order to do this, what we did, we invested in a very scalable microservices-based architecture where no matter where the product is, whether it's calling us from the core desktop product or the mobile apps, or our prospect business or a retention business where people are existing customers coming in to renew, we have this messaging architecture set up in a way that it can provide toaster alerts, it can provide SMS, it can provide emails, it can provide contextual cards that show up in the product. And what powers these messages is really an audience segmentation where marketing can set up campaigns that allow us to say, okay, a specific OEM and a specific day that's on day 1 of their journey or day 30 of their trial journey, they'll get this specific message around engagement or early boards, or it's time to transact now, right? And we also have a lot of A/B testing that we could enable through this messaging platform. And at the heart of it is what we call as a customer 360 platform or a database, which in this data store, this is the power of having a NoSQL database where we are able to get device data, subscription data, user data, machine learning data, as well as product telemetry, all kind of getting synthesized into one unified profile that is being powered by DynamoDB. And so what you'll see here is that the prior solution was really consisting of 3 core databases that utilized Microsoft SQL Server. And while it was good, what we have now is a good to great story, right? So we've basically gone from 1 billion plus write operations a month and storing messages history, device details, user profiles. But there were a lot of challenges. There were challenges around cost. Hosting SQL Server and on-prem was expensive. We had performance challenges. We had issues where the DB reads and writes would fail, and that would cause outages. We had challenges with scaling where we were trying to do horizontal scaling. We were not always able to achieve that. And a lot more operational complexity where we had to roll out and expand every time we did releases. So now, how did we get out of this and into a great solution? We invested in moving to the AWS cloud, first as a lift and shift, and this took us several weeks. And we were able to get to higher uptime, but we were not satisfied with that. We said, how do we truly go to a cloud native architecture where we invested in moving from an RDBMS SQL Server to a NoSQL data store with DynamoDB. We kept the metadata in like an Aurora DB. We also containerized it using Kubernetes. And what we saw over time as we moved this in various phases, we achieved a couple of key benefits. One, our monthly infrastructure cost went down more than 40%. Second, the response times of these messages came down to like sub-seconds. Third, we reached a lot of global scale. We're operating in over 42 different cultures. Our products are purchased across 160 different countries. We got to 3 billion plus write operations, 8 billion plus read operations, and we're still achieving that with 20% growth. So a lot of horizontal scaling. And then secondly, we got with these availability zones provided by AWS, continuous backups and global replication. The advantage of what it did, it allowed us to keep the focus out instead of focusing on infrastructure. Our applications team could really focus on feature delivery and how to improve deliverability and click-through rates and conversion rates. And now as a result of that, we're seeing 99.9% plus uptime, faster response times, and most importantly, higher bookings and revenues and higher satisfaction through NPS scores both internally and externally. So people are more focused on application delivery as opposed to infrastructure uptime, right? So these are some great results, but we don't want to stop there. Backing up into the e-commerce vision that I shared, a key part of our AWS migration strategy is that NGM is just the first application in the stack. Next up, we're taking a global payments platform that powers billions of dollars of revenue for us, is also moving to a cloud-hosted solution in late Q4, higher uptime, global scale. Next up, we're taking our customer dashboard, which is my account, moves to AWS in early 2022, faster loading pages, better experience for our customers. And then we want to move our web store, our shopping cart, all our payment services to AWS, first lift and shift, then cloud native data stores such as DynamoDB, so we can achieve that low latency and global scale to keep growing our e-commerce operations. And so with that, hopefully you get a sense of a case study of how McAfee's utilized DynamoDB to power a next generation messaging platform in the cloud at global scale. With that, thank you so much for hearing me out. With that, I'll turn it over back to Jeff.
Thanks, Deepak. I'd like to thank all of you for joining us today. I hope it was informative. And if you have questions about choosing a fully managed AWS NoSQL database or how you can use DynamoDB for your NoSQL workloads like McAfee, you can reach Deepak, Kanishk, and myself using the contact information shown here. Have a great day.